Hi guys, we're doing question 7. Sorry, I crossed it out. I've forgotten. I hadn't done it. So we're on page 296, so question 7. So the triangle is RST. So this is how quickly you should be able to do questions like this. RT is 9 centimeters. RS is 12 centimeters. No point in losing partial credit by leaving that out. The angle at T is 40 degrees. Find the possible, now that's a single word, possible, the possible value at S, at the angle at S. So they seem to have told us already there's only one. Let's see how that pans out. 12, this is 40 degrees. This angle here is less than 40 degrees. Okay, making this angle here bigger than 100. And you'll find that the possible supplement just doesn't work. In fact, we'll try to learn more about that as we go along and try and figure out regarding the three sides. You see, the angle that can have a supplement as well is opposite some side, and we want to know, is that always the shortest, and so on. So there is something to learn here. Some deep insights to learn. We'll just get on with the problem for now. So they seem to suggest there's only one value for this. So let's go ahead and see what we can get here. Well, we know that the sine of S over 9 has to be equal to the sine of 40 degrees over 12. So let's bring up the 9 and let's inverse sine across. And it makes sense to put the 9, it looks nicer like that. 9 over 12 is 3/4, so I'll speed things along just a little bit. Don't have to do that, you can write it all in if you like, but I'll just say 0.75 times the sine of, let's gamble it, I think it will let me do sine of 40, we'll see. Okay, and it tells me S equals 28.8 degrees. Now before we go on and think we're great because we know our stuff and we need an obtuse situation, I'm going to show you why that obtuse situation is impossible. Well, by calculating it you'll see how silly it is. So roll forward and go 180 minus, and we get S prime candidate, but it's not going to work, would be 151 approximately. Let's stay smaller, and you see that plus 40 is larger than 180 degrees. Okay, so you can certainly see why it's singular. But what I'm going to do is I'm going to calculate this side real quick using the cosine rule, I think. So we'll calculate this side real quick based on what we have here. So I'm going to fill in this extra angle because we want to make some, we want to come up with, try to get a conjecture about when will there not be an obtuse option, and I think we can come up with a hard and fast rule for that. So I'm looking at my angle opposite this side because I'd like to know it, and actually once I get that I can use the sine rule, which is a little bit less awkward than the cos rule, and I need it even for the cosine rule, so one way or the other I need it. So I'm going to go 180 minus 28.8 minus 40. Now I am sorry I didn't write that down, you know, didn't save that exactly, but it'll do. So this is around 101.2 degrees. Okay, that'll give us a side here. Now what's the quickest way? Well, let's try this. Let's use the cosine rule. Now you use the sine rule because you haven't got to the cosine rule yet, but I'm going to use the cosine rule, which is that the square root of a fraction bar 12 squared plus 9 squared minus 9 by 12. Well, I'm using I don't need any downstairs, but that's okay. I'm using the cosine rule, so this better be the cosine, or the cos of 111.2. So if you ever start a fraction and you realize you don't need it, just put 1 in the place, the numerator denominator. That gives me this at 16. Okay, so when we had the shortest side, it turned out we weren't able to get an obtuse. So we'll make this conjecture that the shortest side, opposite the shortest side, can only have one angle. We call it our internal conjecture for now, okay, until we know better. But angle opposite shortest side can never result in supplementary angle also being, I think I should think about writing that again and more concisely, but anyway, also being a solution when using sine rule. Okay, so angle opposite shortest side, which means the smallest angle can never, because the opposite the shortest side, so yes, we could certainly say that more elegantly. We could say the smallest angle never has a supplementary option. Now it does when you're using the area is given to you in a triangle, supplementary option when solving sine rule for angle. Okay, that's my conjecture, and we'll see how that goes. Or we do better than that. Let's try and prove it. Let's think deductive. So I've made my inductive, that's the inductive process. I've taken one situation and I've taken a leap of faith and said, okay, I'm going to just make up this idea. Okay, that's one type of maths. It's terrible on real numbers. It's fantastic on discrete numbers. So you have this thing called induction on the course, which you'll be studying later on. But it's terrible. Well, it's not terrible. It does give rise to a lot of correct intuition and correct conjectures. But it's no good for proving them. As I say, except on discrete numbers, it's good. So we've got our conjecture, got this, and we're going to try and prove it. So we're going to prove it. We can only prove that using deductive thinking, using logic. So let's go ahead and try and prove it. I'm pretty sure what we'll end up with is a contradiction, and that contradiction will probably involve an inverse sign of something larger than 1. That's what I'm thinking. So let's call this the small side, call this the medium side, well, I'll call it the large side because it looks largest, and call this the medium side. And let's call this letter S, letter M, and letter L. Okay, so what I am saying is angle S can never have a complement. So let's see. The sine of the small over the small. Now we have to take two cases. Is equal to the sine of the m over the m, which is equal to the, and the third case, the sine of the little l, the largest angle over the largest side. So let's solve in this case first. So s, little s will be equal to, no, big S, angle S will be equal to the inverse sine of S times little s sine of m over medium side. Holy cow, what's going on here? So my conjecture might be rubbish. Well, we know this. We know s over m is less than 1. And we know that this is less than 1. Oh my god. That means, yeah, but being less than 1 is not enough. Of course it's less than 1 for the acute to exist. Doesn't mean what I have said isn't true. It's just my method of my approach is no good. Okay, we've had a little bit of fun with that, and this is just something extra to think about because we enjoy math so much. But we'll park that for now and we'll come back to it because that didn't work. And it's not going to work here either. Interesting proof, interesting idea. Park it, let's move on. Okay, we're moving on to question 8, but I'll make a new video for that.